we are going to see what that means and why is it very important that blood clots at the right moment and in the right place. So we're going to look at that and what is its role in contributing to wound healing. Okay, if we have an injury, clotting happens, and then this sets the pace for healing. So how does that happen? Okay, what are the sequence of events? Okay, what steps are involved in this process? And then we look at important molecules or important cells that are very important in the blood clotting process, and we see what their roles are. And then we'll also look at what happens if the process of blood clotting is not well regulated. It's what I started with, whether the blood clotting happens at the right place and the right time. If it does not happen like that, then you're most likely going to have problems, and we'll see what problems are those. Okay, so let's start. Clotting of the blood is what we can also call coagulation. That's the term we can use to mean the same thing. It's a process by which a clot is formed to prevent excessive loss of blood through a vessel, through a blood vessel. So when you cut your finger, your blood will flow, but it flows for a few minutes, 1 or 2, and then the flow of the blood stops. That is if it is not a major artery. Okay, if it is not a major artery that has been cut. Okay, if it is a major artery, then you really need to turn such that blood is occluded from being lost. Okay, flowing through that broken artery. Okay, so if it is not a major blood vessel, then the clotting will play a role. Okay, and in stopping that bleeding. Okay, so it happens for that primary reason, but the other reason is that when we have a clot, it means that in that cut hand, when you have a clot, the clot prevents the organisms like the bacteria or the pathogens to enter through the broken skin to cause an infection. Okay, so that is also the other benefit of clotting. Okay, so clotting is basically about that. Just as you can see here, there is a broken skin, and then you see cells here, and then some fibers. This is what we call a clot. A clot is here. You have cells coming together to form a plug, and you have some fibers that are being laid. So when that happens, it means that this place is sealed and there is no blood that is going to escape, and then also you also have no pathogens entering. That's very important. So it looks like it's a simple process, isn't it? Having cells coming to the damaged place and then clamping together, and then some fibers being laid, and then the place is sealed, and then the process of healing starts. It's very simple, isn't it? Yeah, that is it from the surface. But we have a number of cells, a number of clotting factors that are involved in that simple process. And here we are looking at some of them, not all of them, some of them. So the cells that are very important in the clotting process, and we call them the first responders, are the ones we call the platelets. The other time we call them cell fragments. Okay, they're the ones that are very we also call them thromboblasts. Okay, these are the platelets. They are the fast responders. So when you get an injury, the cells that come to that place first and aggregate there are the platelets. Okay, they become sticky and then they clamp together, forming a plaque. That's one component. And then the others are the endothelial cells, the cells that line the blood vessels. Okay, the cells that line the blood vessels. They release very important clotting factors. Okay, they also play an important role in preventing clotting. So they are on this side saying we can promote clotting. They are also on this side saying that we can also inhibit clotting, and that is very important. You don't want blood to be clotting anyhow within your blood vessels. You don't want to have that. If your blood clots anyhow, you will have what you call thrombosis. If I can write it here. A blood clot within the blood vessel. Okay, and a specific example is what we call deep vein thrombosis. Deep vein thrombosis. So when you have deep vein thrombosis, it means that you have a blood clot in your blood vessel, especially the vein, and it happens more to the veins in the calf muscle. Okay, so it can also happen in the thigh, but commonly in the calf muscle. So when you have that problem, deep vein thrombosis is a serious problem because it can result into death. Okay, so you basically don't want to have blood clotting anyhow. So you need clotting. Clotting should not happen. So you don't want clotting that is unnecessary, because you will have problems. So the endothelial cells prevent that clotting. That they play an important role in inhibiting clotting that is not normal. And then we have fibrinogen. Okay, it is a protein, and it is an inactive protein, meaning that it has to be turned into the active form, which we call fibrin. It has to be turned into an active form called fibrin. Okay, so we will see that another molecule called thrombin is one that plays an important role in conversion of fibrinogen into active protein called fibrin, and we'll see the nature of fibrin. Calcium ions are also needed for activating several clotting factors. Just remember that we are looking at the major things that are important in the clotting process, and some of these are cellular in nature, others are basically chemical, the proteins that we have seen and other factors. So we generally call them clotting factors. So some of these are actually in inactive forms and they need to be activated. So we are saying that calcium makes that, or does that. It is involved in activating a number of these clotting factors. So vitamin K, for it is required for producing some of the clotting factors. So if a person has a problem with the liver, they will have a problem with clotting, because some of the clotting factors are made in the liver, and the process of making this clotting factor requires vitamin K. So if a person does not have vitamin K, they are not going to have proper clotting process. And then we have another factor, von Willebrand factor. Okay, von Willebrand factor is an important factor that it allows platelets to adhere to the damaged blood vessel wall and then attract others and also still clamp together and form that plug that we have been talking about. So how does it happen? We are using the word cascade earlier on. It's cascade, meaning that this leads the other and then the other leads to the other, just like that, a sequence of events. And that's what we are saying, that the clotting factor involves cascade reactions, one factor leading to the other. Cascade. This is what we mean. Okay? So, from the first point, when a blood vessel is injured, that means that the blood vessel wall is exposed. Okay? The exposure of that blood vessel wall will result into release of chemicals that will attract platelets. So platelets will respond fast. They will run or they will move towards that injured place. And then they become sticky. They become attached to one another, just like what you see here. Okay, they will stick to one another. So the first step is that when injury of a blood vessel causes a release of clotting factors that will attract platelets, that means the platelets will be activated and then they stick to one another around that place where the blood vessel has been injured. Okay, so the next thing is we have the platelets now releasing more chemicals that trigger a series of enzymatic reactions within the plasma. That's why we call it a cascade reaction. And actually, the process that we are describing here is a summarized version. Okay, it's not a complete. That means when we talk about a series of enzymatic reactions, many reactions are happening, but we are not going into details of these reactions. But these reactions are the ones we are calling the coagulation cascade. Okay, we explained that earlier on. And this is where the vitamin K and calcium play an important role. I already explained that vitamin K is used in production of clotting factors in the liver, and then calcium is used in the activation of clotting factors. Okay, so the platelets release more chemicals that will trigger a series of other reactions. Naturally, our blood has anticoagulants. Anticoagulants are those chemicals that prevent coagulation from taking place. We say that coagulation should not just take place because if it just happens, we have problems. We want it to happen at the right time, at the right place. Okay? So, naturally, we have heparin as one of those substances that will prevent coagulation. Okay? And it means that when this coagulation happens, it should not happen endlessly. Okay, there should be a stop to it, and that is where heparin comes in, and it temporarily at that point of coagulation, it is temporarily inactivated or neutralized, so that the coagulation can happen. And then prothrombin, which is an inactive protein in the plasma, we can call it a plasma protein, is now converted into thrombin, which is now an active enzyme that can convert fibrin fibrinogen, which we talked about earlier, that it is an inactive protein, so it has to be converted into an active one, fibrin. And this fibrin actually forms what we call the fibrin strands, which are basically like fibers, mesh like that form the mesh like network that trap the blood cells and the debris, and then making the plug, the platelet plug more compact, or forming a strong clot. Therefore, just come back to our image here. You can see that there are some of these fibers. Here are the ones we are calling the fibrin strands that form a kind of a mesh network that entangles around these blood cells, forming a very strong blood clot. Okay, and then it means that if the blood clot has been formed, blood loss is actually controlled, or bleeding is actually controlled. The next thing is the healing to happen. Okay, so that means that the healing is enabled if you have a proper clot that has been formed. This fibrin, this clot actually contracts, making pulling the edges of the damaged blood vessel closer, and this promotes healing, and eventually the healing process will start to happen, where different cells will come to remodel that area, the tissues, and put down different mechanisms of what healing will happen. Okay, and then that is basically the retraction and the wound healing, which is basically the last part of this blood clotting process. Okay, so blood clotting is very important because it prevents bleeding, and then secondly is that it prevents entry of pathogens into the wound, but also the last point is that it lays the foundation for healing to happen. Okay, and we have said that there are several factors that are involved. We have the platelets as the major players, the first responders, attracting more platelets and releasing more chemicals that will set the events to happen, which we call the cascade events, or coagulation cascade that will happen. And we said that if coagulation does not happen in the right place, you will have clots that are being formed in the different parts of the body, and that can be dangerous because it will end up killing